Hello everybody and welcome back. Welcome back. I hope you're as eager as I am for question number 15 on the Pascal paper from 2004. So let's dive in and take a look at it. In the Pascal family, I wonder where they got the name. In the Pascal family, each child has at least 2 brothers and at least 1 sister. What is the smallest possible number of children in this family? Okay, so if we, the obvious answer is 0. If we had 0 children, then every single child that I could hunt down in that house would have 2 brothers, and at least 2 brothers and at least 1 sister. But that's vacuously true. If I can't find any children, then there aren't any children to ask, do you have brothers or sisters? But they don't give us the option of 0, and frankly, that's a bit pointlessly tricky and trying to work around the question. So we could have 3, 4, 5, 6, 7. There's not really any particular place I'd want to start with this, but obviously there will be a child. Okay. So there will be a child. Okay, so tiny little kid. If this kid is a boy, he has to have 2 brothers and 1 sister. So that would mean that there's him, and then 2 brothers and 1 sister. Okay, and that would be 4 family members. Great. If this kid is a girl, well, she still has 2 brothers and 1 sister. So I haven't really added information here, have I? Well, actually, I think I have. So she would have to have, again, 2 brothers and 1 sister. So here's the kid that we've got. And she has to have 2 brothers and 1 sister. That would still be 4 kids, but the composition here has changed a little bit. Right now we have 3 boys and 1 girl, but here we have 2 boys and 2 girls. So 4 isn't the right answer. So let's stop for a moment and take a look at this family. Now maybe 4 is the right answer. Maybe one of these families will work. So this boy is happy. He's got his 2 brothers and 1 sister. This boy has 2 brothers and 1 sister. This boy has 2 brothers and 1 sister. This girl has at least 2 brothers. Here's 2 of them. But needs a sister. Okay? And down at this family here, this sister's got 2 brothers and a sister. She's happy. This sister's got 2 brothers and a sister, but this boy only has 1 brother and 1 sister, and at least 1 sister. So the boys aren't happy. We would need another boy to satisfy them. And now we've got 2 families that do look alike. This family of 5. So let's flip the page and start with a family that's got 3 brothers and 2 sisters, and everyone should be happy. Okay. So we have our 2 sisters. Don't forget to give them legs. Okay, so 2 sisters and 3 brothers. So is she satisfied? Does she have at least 2 brothers and 1 sister? So sister, 2 brothers, she's good. How about this sister? Yep, she's got a sister and 2 brothers. She's good. This brother, he's got a sister, and he's still got 2 brothers, so his condition is satisfied. This fella here, sister and 2 brothers, fantastic. And the last brother, he's got 2 brothers, and he's got a sister. So this family works. 5 works, because every kid here has at least 1 sister and 2 brothers. Some of these kids have more sisters than are required. Some of these kids have more brothers than are required. That doesn't matter. We want at least 1 sister and at least 2 brothers for every kid. So 5 works. And we want to do, we just bubble in 5. 5 works. We definitely ruled out 6 and 7 because we know 5 would be a family that works. But let's just double check. I just want to complete the sort of logical thought. What if we had a family of 3? What if we had a family of 4? Okay. So let's take a look there. And we've sort of already covered that. I just want to sort of flesh that out. So what if there was a smaller number? I guess is what I want to say. So if we had a family of 3, child, I'm not going to give them genders here with skirts or whatever. This kid needs at least 2 brothers and 1 sister. That means he needs at least 3 other kids. There's 1 missing. So 3 will never work. As for a family of 4, we have 4 kids. But then we saw if this one's a boy, so this one's a boy, then we need 2 boys and a girl. But then this girl does not have 2 brothers and a sister. She's only got 3 brothers. So she's unhappy. So what if this kid was a girl? Well, still needs 2 brothers and a sister. At least 2 brothers and at least 1 sister. But then these boys here are unsatisfied. They don't have at least 2 brothers and at least 1 sister. They got 2 sisters, but only 1 brother. So that sort of completes the logical thought. No other smaller family will work. 5 is the smallest. And we have to double check that because maybe we made an error. Maybe there is some special family of 4 that we just didn't think about that does work. And you might say, yes, that's obvious. Of course 5 works, and we were very easily able to rule out 4. But you notice that even though I did start talking about a family of 4 at the start, I did say nothing about a family of 3. We do have to double check these things. If not for this contest, if not for the grade 9 Pascal contest, then for when we're writing the Euclid contest where we can get scholarships and logic and reasoning have to be written out and everything has to be complete. And sometimes the questions are harder and things require more justification. Good time to practice that is when you're practicing the smaller contests like the Pascal and the Cayley. Okay. But we've got our answer, 5. I think they did these in numerical order, so I'm just going to throw it out there. I'm pretty sure this is C. And I confidently switch back and see, yes, C, 5. There we go. Okay. Not a bad question at all, and we're going to move on to question number 16.